All right, welcome back. Today we're going to continue on the basics of both C and Java, and then transition eventually, especially by Thursday, into basic conditionals. Remember that we are online, so if you have questions, you can post to Piazza, or you can have a discussion on the YouTube chat. When we left it off last time, we were looking at variables and the different types of variables. We looked at the three, there's many other types of variables in both languages, but we're going to focus at least initially on these three, the integers, the doubles, and the chars. And remember that, let me go ahead and increase the size a little bit here. There we go. Let me know if in the back it's not readable or not. Hopefully, as you've already observed, you have to declare variables before you can use them. You have to declare them up here, and then you can use them down here. You can't use them up here and then declare them down here. When you declare a variable, you have to provide the type of variable. So this is going to be an integer variable, an int variable, or this is going to be a double variable. And its type cannot change. And you also need to provide its name. Optionally, at the same time, you can assign it a value, or you can assign it a value later on, because of course they are variables. They can vary. They must be declared before they can be used. There are some other programming languages that are different, that you can just start using variables. You can change their types. Those are called dynamically typed programming languages, JavaScript, PHP, Python, things like that. But both of these languages, C and Java, are statically typed. You have to declare the variables before you can use them. And also, they must be in scope or visible for you to use them. To show you what I mean by that, again, let me go ahead and come over here to Java, for example, and let me go ahead and create an inner scope, right? So what I mean by that is, remember that we've got these curly brackets. You can go ahead and create a block and a new scope inside of this main method. And if I create a variable inside of this, int x is equal to 10, outside of that, if I try to if I tried to print it, for example, system.out.println x, right? It's not going to let me do that. It doesn't know what x is. X was declared inside of this code block. Its scope is limited to that code block. It exists on line 18. If we want to, we can print it out on line 19, and that's perfectly fine. But as of line 20, it is dead. It is gone. It's out of scope. So when you create a variable called x in one function and another variable called x in a different function, those are different variables because they have different scopes. Generally, you want to limit the scope of variables as much as possible, and we'll see that when we start on loops next week. Okay? But that's what we mean by scope: the area of code in which a variable is visible or exists. It starts where you declare it, right? And that's the beginning of its life cycle. And then at the end of its scope, it dies. That's the end of its life cycle. Okay? What about some operators now? Because once you have variables, you need to operate on them, right? The assignment operator is the first basic operator that you have, or the single equal sign. Assigns values to variables, and as variables, right? And as you've already seen, it's simply the assignment variable takes whatever is on the right-hand side, which can be many different things, and puts it into a variable on the left-hand side. So let me go ahead and go into code mode here. Int x is equal to 10, or I can just go ahead and declare x. At this point, what value does x have in in either language? If I just declare a variable. Well, yeah, what value does it have right now? No value? I heard in magic word there. Null, maybe? Right? I don't know, right? In neither language is it defined. So in C, it could be anything. 99 times out of 100, it's going to be 0. But it's that one time out of 100 that it's just garbage values. We sometimes call that dead beef. Dead beef is a hexadecimal code used to indicate uninitialized memory. So it could be whatever was in the memory location that was there before, right? Now, again, 99 times out of 100, it's going to be 0. If I tried to print this out, it might be 0. By default, there is no definition in C. What about Java? Let's find out. Let me restore what I had before, right? And instead of assigning a value of x, let me go ahead and print it out. It might be difficult to see that, but can you see that it's not compiling? There's a little red X under it. Why? Let's hover over it and find out. The local variable X may not have been initialized. In C, it's perfectly fine. It'll have some garbage or random value, or maybe 0, cross your fingers. But in Java, you can't even do this. An uninitialized local variable has no value. Therefore, if you try to use it, if I tried to add it to something else, if I tried to print it like I'm doing here, it's not going to allow me to do that. You have to initialize your variables in Java. Right? All right, so let's initialize it. Set the value of x to 10. Right? X is equal to 10. Right? Later on, you can reset it. Reset its value to another value. Right? X is equal to 20. Right now it's 20. Whatever value you happen to assign it, that's its value until you change it. It's a variable. It doesn't. That thing on the right-hand side, by the way, is what's called a literal. 1, 0. It's literally 10, right? It's literally 20. You can assign literal values, or you can assign other values, right? So set a value to this is a literal. Right? You can also set a variable to variable's value to the value of another variable. And that's going off of the scope there, so let me go ahead and put that onto 2 lines. There we go. Otherwise, when it gets pushed out to GitHub, it'll render fine. So I'm going to go ahead and create another variable at y here and set it equal to 30. Right? Now what I'm going to do is I'm going to change the value of x to be y. Right? X now has a value of 30. Let me go ahead and change the value of y to 40. Right? Now y has a value of 40. What value does x have now? Is it 40? It's only 30, right? It only copies the value at the time that you use the equal sign. It doesn't marry those two variables together. We will look at a situation where later on where we have pointers or references where we can have multiple variables point to the same location in memory, in which case if you change one, then it's reflected by the other. But in this case, all the assignment operator is doing is saying, take the thing on the right, the value on the right-hand side, and put it into the variable on the left-hand side. Right? You can also have full expressions. You can have full mathematical expressions. For example, I don't know, r is equal to, here, let's go with a is equal to 10, or actually, let's do something before that. Int a is equal to 10, b is equal to 20, c is equal to 30, right? So you can declare multiple variables with multiple assignments in both languages, right? So here I've declared 3 variables. If you want to put them on one to a line, that's fine. But you can't mix the types, of course. You can't have A is an integer and B is a double, right? You'd have to have different declarations for that because you have to provide the type of variable, right? But now you can go ahead and create an entire expression here. R is equal to, let's say, B times B minus square root of 4 times A times C. Am I getting it right? Divided by what? 2. Oh, 2A. Okay. Let's do it like that. Is that correct? 2A. Oh, it's mathematically correct, yeah. But in code, nope. We need an explicit multiplication there. And that's another operator. We'll talk about these here in a second. But that thing on the right-hand side is an entire expression. What is it, by the way? part of the quadratic formula, right? The first part. You can't have plus minus either because that's not even correct math. It's just a shorthand way of saying that there are two roots to that quadratic equation or whatever. It's half of that quadratic formula. The entire expression on the right-hand side is evaluated. It has a result because A, B, and C all have values. Whatever those are, they get plugged into that expression. The expression has a result, and that result is placed into the variable on the right-hand side, in this case, a double variable, right? Obviously, because we'll want to be dividing and taking the square root and everything like that. What would that look like in Java, by the way? So everything that I've done up to this point, both languages, exactly the same, except for this square root. We don't have the square root in Java. We have it in the math library in Java. So it had to be math.sqrt. Okay? Yeah, go ahead.
Anything they use from a library in Java, you have to specify what library it's coming from?
In general, yes, but math is in the java.lang, so it's so common that it's there automatically. For example, I don't know, double foo is equal to math dot square root of, what's the square root of 2, right? I did not have to bring that in up here, like I had to bring in the scanner last time, because that's in java.util. But anything in import java.lang.math, there's the math library. But anything in java.lang, it's part of the language itself, it's automatically imported. So we don't need to worry about it. But we do need to prepend it with the class name and then the function, right? Those are static methods. We'll talk about that later when we get into classes and stuff like that, okay? All right, so that's one type of variable, or it's one type of operator, excuse me. You also have arithmetic operators, right? So we've already seen a couple from above, right? Plus, minus, multiplication, division, etc. So arithmetic operators follow PEMDAS, right? Remind me, what does PEMDAS stand for? It's just math. Parentheses, exponents, multiplication, division, addition, subtraction, right? That's the order of operations. The same order of operations from your math class, from your arithmetic, from grade school, applies here. If you want, for example, why did I have to go with a parentheses here and a parentheses here? Because I needed to make a quotient. I needed a numerator and a divisor, and I wanted everything grouped up here, so I had to put parentheses. The following are not the same. If I did, say, A plus B times C is not the same as A plus B in parentheses, and then multiplying by C, right? Those are not the same because of the P in PEMDAS, right? So you just need to make sure that you are that you're keeping track of that. There's another operator. It's the integer division operator, and this has been both languages. The percent sign. It does not compute a percent. It does not change 40 into 40%. It is the remainder. Right? It provides the remainder after division. Right? So for example, if I went with 10 divided by 3, just temporarily here, 10 divided by 3, what normally is that? 10.333333, right? But now think back to your grade school days, before you knew about fractional numbers. What did you do? You went 10, 3 goes into 10 how many times? 3, and then what did you write over here? Remainder 1, right? Hopefully that's in the, that was caught on my webcam, if not, but that's fine. That you have a remainder 1, has a remainder of 1, right? So that's what the percent sign gives me. It's a division, but instead of giving me that quotient, it gives me the remainder. It gives me, it has a remainder of 1. Here's another example. What if I did 10 And we also call this mod, so 11 mod 3. If I did 3 goes into 11 3 times, what's its remainder now? Of 2, right? What if I did 12 mod 3 is what I wanted. Has a remainder of 0. So you can have whatever your modulo is, that other thing right there, it can have remainders of 0, 1, 2, 3, up to that, but not including that. So you can't have a remainder of 3 here, right? Because if you had a remainder of 3, well, 3 goes into 3 one time, and so that would come over here, and you would have no remainder, right? Another example, 11 mod 2 has a remainder of what? 1. And 12 mod 2 has a remainder of 0. Good. Why is that useful? It gives you a way of telling whether or not something is even or odd, right? Excellent. Now, this is in both languages. There is a slight difference in C in that a remainder can be negative. If you take negative 11 mod 3, what's your remainder then? Negative 1, all right? That's weird, all right? 2, sorry, negative 2. But in Java, I believe that you have a guarantee that it's always going to be positive, okay? Variable naming, right? So both languages have rules. Both languages have identifier naming rules. They may consist of letters, both upper, lowercase, numbers, underscores, etc., but may not begin with a number. And that's mostly for convenience, because if a parser, if a compiler starts trying to compile your program and starting to parse it out, it sees a number, it immediately thinks, okay, I'm in number mode, this must be a number, right? This must be a literal. If it sees a letter, oh, okay, this must be a variable. It just makes it way easier to write compilers. So you can't begin with a number. It's not a good idea to put a number into a variable, right? In general, you must adopt a clear and consistent naming convention. General, sorry. Our suggestion, our strong suggestion, is that you use lower camel casing. All right, how does that work? Lower camel casing? If you've got first of all, if you've got a variable with a single word, don't pluralize it. Use all lowercase letters. If you've got a variable with multiple words, number of students, annual percentage rate, something like that, then the first letter of the first word is also lowercase, but the first letter of each subsequent word is uppercase. And why would you want to do that? What if I just did it all lowercase? What would that look like? Here, let's look at some examples here. If I did annual percentage rate, there we go. Yeah, it's hard to read, right? It's just a bunch of words strung together and, you know, forced together, concatenated together, right? Whereas if you have, in fact, it could become ambiguous. It looks like aggregate to me, right? But if I make sure that they're all offset by capital letters there, absolutely clear, right? Or number of students, right? Now, students is not necessarily pluralized here because it's number of students, right? It's all a phrase, right? So it's a pluralized phrase. I don't remember my grammar enough to remember what that would be called. But generally, you want to avoid pluralizations unless it's a collection, like a list or an array or something like that. That is our strong suggestion. There are alternatives. Alternatives would include lower underscore casing. And that's an old school way of doing it in C. In fact, you'll see that in a lot of places with C programs. Why is it not our strong suggestion? Think about what you have to do when you do an underscore every single time.
Shift.
You have to shift, so you're hurting your pinky. You're going all the way across the keyboard. It is much more difficult to type. It slows your touch typist skills down. Not only that, but after a while, your pinky finger will fall off. So we highly suggest that you save your pinky finger. Don't get early arthritis, and go with the much easier to type, much easier to read lower camel casing convention. Right?
Is upper camel casing just doing the first letter?
Exactly. That's going to be upper camel casing. In Java, upper camel casing is reserved for class names. Right? For example, KMS to miles. We used that last time. Now we did break a rule, not a rule here, but we kind of went against the guideline in that you should generally avoid abbreviations, acronyms, etc., unless it is absolutely clear. Right? So don't use mysterious, like APR. If you are in a financial application, right, and everything around you is finance, then yeah, sure, APR is probably a well understood acronym, annual percentage rate. But if you take yourself out of that finance context, APR, what the heck is that? I'm sure that there are other alternatives of what stands for APR. Avoid those acronyms unless it's absolutely clear. Avoid abbreviations, because it is always best, you're not paying by the word, right? Go ahead and type it out, right? You're not paying by the character, that is. So make sure that because remember, variable names, they're not for the computer. They're for other people to read and understand your code. They're for you, after you come back a month after you've written this code, to come back and look at these variables and say, okay, I know what this is doing, I know what this is doing. Absolutely, you should not have non-descriptive variable names. In general, you should avoid things like X or foo, bar, baz. X is okay if you are doing some sort of mathematical thing where you've got X, Y, and Z, and they don't necessarily stand for anything. But if you've got a program where your variable is modeling something, like, say, balance or savings account balance, name it that. Don't just name it X. Right? Don't use the placeholders of foo, bar, and baz. I will do that frequently, but only as an example of syntax. Those are just nonsense words, or like placeholder words, but you should not use that in a real program. And you certainly should never use something like variable A, variable 1, and then, oh, I need another variable, variable 2, variable 3, etc. Right? Definitely never do that. That's extremely bad style. Because if you have variable 1, variable 2, variable 3, you come down here, okay, I need to multiply variable 1 by variable 2. Or was it variable 3? What am I doing again? Right? You start to lose the forest for the trees. Because you don't have good variable names to begin with. Right? Okay? Questions on that so far? No? All right, again, avoid pluralizations. If I have a balance, it's certainly not balances. If I have a list of students, then sure, call that students because that's a pluralization, right? It needs to be understood. So in general, your variables should be immediately identifiable. All right, let's see, what else? I'll just cut and paste this since we already talked about it. Default values. In Java, if you do not assign a value, the variable cannot even be used. That's a compiler error, as we saw before. In C, there's no default value for uninitialized variables. It could have garbage values, dead beef, right? Or whatever. Naming more operators. So pitfall, truncation. Right? So let me go ahead and go over to, I don't know, here. I'm going to, here's some useful commands. How many people are already comfortable with the command line? 1, 2, okay. You will get more comfortable. I don't think I made this post in the honors section, Piazza, but I did make it in the regular section because it never came up in this section. People were having trouble putting in their password into GitHub. They would type it out, and then they would what's going on? It's not doing anything. Well, first of all, you got to hit enter, right? Because the computer is sitting there at the command line expecting you to type something and then telling it when you're done typing. And to do that, you need to hit enter. Then they also were baffled by the fact that it wasn't showing anything. That would be a security risk. And I finally realized what was going on because, and this is not necessarily true of everyone, but everybody grew up with, say, phones. And when you type in your password into a phone, what happens?
It shows you for like a second.
It shows you for a split second because this is a terrible input device, right? It needs to give you a little bit of visual feedback to say, yeah, you hit the right button, because they're so small that you don't know whether or not you hit the right button. And so it needs to give you that visual feedback. It also tells you, then it disappears and becomes a dot, but it still tells you the length of your password. Even knowing the length of a password is a security risk. A command line is way more sophisticated because we have an actual QWERTY keyboard input. That's our standard input. And so I finally realized that people were understanding what was going on because they were used to different security measures, right? Unsophisticated input devices like a phone versus a sophisticated device like an actual command line, right? So the point of that post that I made in the other section was that as you go along, you will become more familiar and more comfortable with the command line. It does have a steep learning curve. But once you've gotten over that steep learning curve, you will find that you are 1,000,000 times faster. Well, not 1,000,000 times faster, but you are far faster at doing tasks at the command line than you ever were doing point and click interfaces. That's why they're called power users, right? That they can do a hell of a lot really, really quickly, and they can be very, very productive by just using command line stuff. Yeah. Uh-huh.
So sometimes when I accidentally type a command wrong, and I press enter, it changes to instead of being /honors, there's a side arrow, and
A side arrow, or
yeah,
like that?
Well, I think I've seen what he's talking about. There was
Like that?
There was a GitHub comment thing.
Yeah, okay. So git commit m blah. That? So what happened there? I didn't close my single quote there. It's okay, just close it here. You can have multiple line comments, right? And it's going to tell me that it's not even a GitHub repo, but you just eventually need to close that that message. Right? That's waiting for you to enter more and to close the comment and be done with it. Is that what you observed? Okay. Does that answer the question? Okay. All right, where am I now? There we go. Now I'm back in my directory here.
What directory were you in when it
Oh, good question. That is the root file directory. That's at the very top of everything, right? The hard drive, for lack of a better term, because there is no physical hard drive here. It's all virtualized. How do I get back to my home? Tilde. And what is my home? PWD tells me what the current working directory is. Home Ubuntu. I'm Ubuntu. You're all Ubuntu here. But if I were to do this in my own machine here, I'm in users C Burke, because now on my computer I'm C Burke. But up there on the CS50 IDE, I'm the user Ubuntu.
Are they all virtualized user systems?
And it's virtualization of virtualization. These are Docker instances. So it's just Cloud9, which is an AWS, Amazon Web Service, that we are piggybacking off of Harvard for until they tell us that we can't do it anymore. I asked them a couple of years ago, can we go ahead and use this? And they said, yeah, it's for the world. They're footing the bill, though. So when the bill becomes too much, then we're going to have to rethink using CS50 IDE.
Very convenient.
It is very convenient, isn't it? It's okay. I've got 10 other things that we could switch to. Not as good. Not as good from my perspective because it's so easy. GitHub, do this, you're done, right? Bada bing, bada boom, we're done. But for example, if you go to any GitHub repo and hit period, that opens up a virtualized Docker instance, I believe, maybe, of Visual Studio. Right? Okay. Any other questions as we go along of this kind of stuff? No? Okay. So where were we? Truncation. I'm going to go ahead and copy KMS to miles. Oops, we're not on honors. There. I'm going to copy KMS to miles to demo.c so that I have this other file here, and it immediately shows up, and I can just start playing around with this. So what I want to do is I want to create some variables here. A is equal to 10, or A is equal to 10, int b is equal to 20, int c is equal to a divided by b. And let's go ahead and print. We'll talk about placeholders in a moment here. Let's print out c. I'm going to go ahead and compile this demo and try to run it. Predict before I do what value c is going to have. What should it have? 0.5, right? 1/2. It's got 0. Why? It's an integer. An integer divided by an integer is going to result in an integer. So what happens here is that we have 10 divided by 20. That's 0.5. Well, we can't store that into an integer, right? So what's going to happen is we're going to take that 0.5, chop it off, and throw it away. All right, fine. Let's go ahead and update this to be a double. Right? And instead of printing out a double or a decimal, I'll print out a floating point number. Is that going to fix my woes? Nope. Because an integer divided by an integer is still going to be an integer. It doesn't matter. What happens is 0.5. Okay, well, the truncation, this is called truncation. We're truncating it, and we're throwing it out. 0. Well, yeah, C can store 0.0, just like we can see it here being printed on the screen. But the operation itself is where we lost that fractional part. Right? So when you have an integer divided by an integer, the result is always going to be an integer. The way that you solve this is through what's called typecasting. I'm going to temporarily force b to become a double. So instead of 20, it's going to become 20.0. Now I've got an integer divided by a double. The result can now be a double. So it will be 0.5, and that's what ultimately is stored in that variable. Right? This is called typecasting. Right? I'm temporarily changing the type of the variable to something else. That doesn't change the variable at all. Right? It doesn't change its value. It doesn't change its type. B is still an integer. B still has a value of 20. It only changes it for the purposes of that one expression, temporarily. Okay? And that's called typecasting. So, I'll go ahead and make sure that you've got all of this in the notes. Yeah, go ahead.
So what would be the result if you typecasted A to a double and then divided it by B as an integer?
Okay. A to a double. And then B to an integer. Well, it's already an integer. I don't need to. Right. This will give me the same result. You only need to do at least one of them. You can do both if you want to, but why do twice as much work when half as much work gets the job done? It's that's not that arduous. You're just typing double instead. But you can do either one. You can do the numerator or the denominator. At least one of those has to happen, though. Note that this is not rounding. It is not flooring. Rounding would be rounding up or rounding down. Flooring would be, even if you had 1.9, you take the floor, you always go down to the next integer. That's kind of what's happening, but it's not exactly. There are, for example, it doesn't work for negative numbers. Truncation is simply looking at a number, looking at the decimal place, cutting everything off to the right, and then just taking the whole number part. Right? The solution is to use temporary typecasting. And by the way, that this works in both languages. but I'll make sure that you've got this snippet as far as C goes. In fact, I wonder, what would happen if we did this in Java? So go ahead and get rid of all this. Cut and paste. Well, first of all, we can't use printf, can we? System.out.printf. Oops. We can use that. This will result as before, because we are doing the proper typecasting on line 20. What if we did not do proper typecasting on line 20? Right. Then we get the same behavior as in C. And now I've worked backwards now. Now let's go back all the way to the original, where C was an integer. Right? And let's try to run it. Uh-oh. Well, okay, that's because this is a double. This should be a double here, or a D instead, and still 0. So same exact behavior in both languages. Okay. What if I tried to typecast it though? There we go. Now something goes wrong. So let's walk through this one example, because this is the only difference between the two languages. On the right-hand side, I have an integer divided by a typecasted double. So an integer divided by a double. The result is going to be a double. I'm going to try to take this double, and I'm going to try to stuff it into an integer box. A double is going to be 64 bits. Can I shove that into a 32-bit box? Nope.
You gotta change the percent D to F.
No, I could do that if I wanted the remainder, but I don't want the remainder. I want 0.5. And what this is saying, in fact, let's read the message. Type mismatch. Cannot convert from a double to an integer. All right? Well, you can if you just be explicit about it. So take that result and say, I frankly don't, int. There we go. I frankly don't care whether or not there's a fractional part or not. Force it to become an integer. Force it into that box. Well, when those 64 bits are forced into that 32-bit box, half of some of the information is lost, and ultimately this is going to end up being 0 again. Right? So the only difference is you can't force it in a double into an integer variable without doing an explicit typecast like this in Java. See, you can do that all day long, right? Yeah.
Can you ask like Java to like give you the amount of precision you want the doubles?
No, you cannot. It's an IEEE 754 floating point number, period. We're done. Now, in Java, you can have, I want pi out to 50 decimal places, right? Say that I do. Or I just want to mash my keyboard here and have arbitrarily large numbers. You can do that, but you need to use big integer, you got to spell it correctly, A, and big decimal, B. Those are different classes, and actually you have to bring them in. Import java.math and import java.math. It's not java.lang.math. It's java.math, so it's not part of the standard library. This can be an arbitrarily large number. And the way that you do this is a new big integer, it's going to be big integer dot value of, oh no, you can't do it that way either. It'll be new big integer. I forget how to do this off the top of my head. Sorry. We'll figure it out here though. Now I can convert as big of a number as I want, right? And I can go ahead and print it out, system out.println A. And you can see that it supports an arbitrarily large number. Right? Yeah?
So, but then like when we had our 0.5, like can you just ask it to like not show the...
Oh, that you're talking about formatting, right? 0.5 and then a whole bunch of zeros, right?
Yeah.
So let's go ahead. That's actually the next thing that we'll talk about here with standard output. Okay. Questions on the basics so far, though? All right, then let's talk about basic input, basic I/O. Let me go back over to the notes here. Right, jump down. What does I stand for? Input. What does O stand for? Output. Great. So both languages support standard input and output. So what does that mean? Standard input is your keyboard. Now, we live in a world where we have a lot more input devices now. Your phone has gestures, right? You can tap, double tap. You can zoom in or out, whatever this is called. You've got mice. You can set it up with a Kinect or a VR system, and you have gestures, right? Hand up, hand over. In fact, I do a VR course in the spring, and one of the excellent projects from this last year was a Tai Chi VR experience. And so it was really, really cool what they did, is that they recorded them, so they hooked up not only VR, but they hooked up a Microsoft, not Azure, not a HoloLens, their whatever the Kinect became. I forget what it's called, but basically it's a 3D camera that can that has a development kit that you stand in front of it, and it detects your hands, it detects your arms, etc. And so what they did is they recorded Tai Chi positions, and then they animated this this Tai Chi master, and you can check it out on my YouTube channel and download it if you've got all the equipment to run it. And so it taught you Tai Chi, like, okay, this pose or whatever it is, right? I'm sure that you could do something with that, like that with yoga or whatever. But these gestures, hand up, hand down, right? They were recorded by them. These are brand new gestures. So you've got different input devices now. But unfortunately, we're going to start out with just the standard input device, which is you mashing your keyboard. The standard output is your terminal. And of course, now we've got a whole bunch of different outputs. You have Windows, you have graphical user interfaces and stuff like that. We're going to stick with the terminal for now, okay? The standard input in C, so standard input in C, we're going to use scanf. Right? When invoked, scanf blocks the execution of the program, allowing the user to enter in whatever they want until they hit the enter key. That's their indication that they're done entering stuff. Then scanf scans the input for a formatted for a formatted input. I don't like using that same term over and over again, input, input, input. But that's basically what it does. So if you prompt the user for input, please enter an integer, and they enter 1, 0. Enter. Right? Then it looks and sees 1, 0. Okay, I'm going to interpret that as 10 because you're a human and you think in base 10. Right? It's not going to be a 1, 0 binary. Right? And that's exactly what we did before. Let me go ahead and restore that code. Printf. Enter on integer, please. Always be nice, right? Say please, and thank you, or whatever. And I'll go ahead and create an X here. Scanf. And we'll talk about placeholders here in a moment. And then we'll ultimately read in X. And then let me print it back to the user. Printf, you entered %d in the line. Right? And I'll print out what they entered, okay? So let's go ahead and compile this and see what behavior it has. Just like the kilometers program, please enter an integer, 1, 0. I'm a good user. They asked me for an integer, I gave them an integer. And so it successfully reads that format. Now, let me be an ID10T user. An ID10T user is an idiot. Hello. Right. You entered in 32766. Now let me try that again. 32764. Right. Yeah. Right. Another number. Right. Just random garbage. Right. Because scanf expects a certain format. In this case, the format is a decimal number or a digit number. Right. So scanf uses one of several placeholders. right? For int variables, it uses %d. And that's just shorthand for decimal, or not decimal, but digit, excuse me. For double variables, it uses %f, shorthand for floating point number. And actually, you should be using lf. Because there are floats in both languages. They're only 32 bits. They're not even half as precise as doubles. And that's why they're called doubles. They are double precision. They have 64 bits. You can represent about 16, 17 digits of precision. With a float, you can only get about 6 or 7 digits of precision. So that's why I'm not even covering them. Just use doubles, right? For a char, a single character variable, it uses, this is the only one that makes sense, by the way, because it matches the variable, char c, double lf, int d, right? No, it should be I, it should be D, and it should be C, right? Because they match they all match up. I didn't write it, right? That's the way I would have done it back 40, 50 years ago, but that's not how they did it. I and a whole bunch, there are dozens of other placeholders, by the way, and I is already reserved, F is already reserved, H is already reserved, a whole bunch of other things that you can do with printf and scanf using different placeholders. We're only going to keep to these three so far, okay? So what happens if you use the wrong placeholder? I ask them for an integer, I expect an integer, but I say, treat it as an LF. Right, first of all, it's going to be a warning. The compiler is being good to me. It's saying, yeah, that doesn't look right to me, right? You have a placeholder here for a double, but you're trying to put it into an integer. Are you sure that's what you want to do? Warning. Oh, okay, if you're sure that that's what you want to do, I'll let you do that. Right? Again, C is a programming language that says that if I want to shoot myself in the foot, it'll ask you what caliber you want. Right? Go ahead and do that. But Java is a little bit more safe in that the compiler will try to save you from yourself. When I do this, if I enter in an integer, oh, wow, cool. Stack smashing detected. Excellent. That is really cool that it did that. Don't worry about what we're doing here. Basically, that analogy that I had before, that we've got the 64-bit number that we're trying to shove into a 32-bit box, right? When we shove that in there, we are taking over memory that doesn't belong to us. We're smashing our own stack, and that's what's coming. It's coming up as. Let me go ahead and try a different tact here so that we can see what another consequence here. So I will make it into a double, but I will read it as a integer. Now let's find out what happens. Right, again, a warning. 10. 0. Right. All right. 10.5. Also 0. Right. I'm getting unexpected results here. And I could probably tell you what's going on there, that 10.5 has is 60. I'm looking at only 32 bits, but those 32 bits happen to be 0, and the 10.5 is over here, and I'm missing it entirely. So I'm only reading this part, which ends up being 0 and not what I want. Right? So heed your warnings. If it's giving you a warning, there's probably a pretty good damn reason why it's giving you a warning. Address those warnings. So if you don't use the correct placeholder, bad, unexpected things will happen. Yeah?
Why did you put %f, not %lf? What is the %f?
Oh, that's because I'm printing. We'll talk about that in a second with the output. All right? For now, just remember the magic. Remember that you have to put an ampersand in front of your variable using scanf. If you want a preview of it, that's basically getting the memory address of that variable so that it can pass it by reference, so that it can pass the memory address to this function called scanf instead of the value of the variable. Let's find out what happens. Let's fix everything first, everything else, LF and F. All right, let's find out what happens when we don't have the ampersand. First of all, another warning. That doesn't look right to me. You have a double star, which is a pointer. and you're trying to use a double here, again, that doesn't look right to me. Maybe you forgot something there. Okay, let's go ahead and find out what happens. Enter an integer. Segmentation fault. Right? I'm trying to access memory that doesn't belong to me. It's not even, it's kind of like the same thing as the stack smasher. A stack is memory that belongs to you, but you shouldn't be mucking with. Now what I'm doing is I'm accessing memory that doesn't even belong to me. It belongs to the system. It may not even exist. And you don't want that happening. I've violated my segment of memory, giving me a segmentation fault. That's where the term comes from. Okay? Just for now, remember that it's magic. You have to put that ampersand in there. Right? Put that ampersand in there. Let's see it all working once again. 10.5, and now everything is hunky-dory. Right? Yeah?
So, if you get a segmentation fault, or if you violate your memory or someone else's memory, or like a memory that doesn't belong to you, would that mess with your other files?
Nope, hopefully. Go ahead and cross both of your fingers. Usually a good operating system tries to sequester individual programs. You could violate user space, and you could bad things could happen. That's a frequent avenue of attack. Buffer overflows, where you do try to get memory locations that don't belong to you, and if you're allowed to do that, oh, now you can start doing stuff. Now you can start stealing the contents of memory, and if it's sensitive, like passwords or cryptographic hashes, like your GitHub password or PAT, great. Now I've stolen your identity essentially. Or I can even be more malicious, and I can start. If I have access to that chunk of memory, I can write to that chunk of memory, and I can inject my own code into that chunk of memory. And if I do it just right, I can get your program to start executing my code to do whatever I want. Right? And that's the holy grail of intrusion. Awesome, right? Now you can do some real damage. Right? You're not going to be able to do any damage. If you do, then it's the CS50 folks that have to deal with it, not me. Right? Yeah, try to break things. See if you can.
I heard about the file I/O incident.
Oh, what's this? What?
Someone was like, they were writing to files on the server, and like.
So yeah, you can so like in the grader and stuff like that on the CSE server. Yeah, so you can when we do file I/O. Eventually, we've got checks and balances against that. I've got a cron job running periodically, so that if your programs do run more than 5 minutes, or I guess maybe it's 3 minutes, I forget what it is, it kills them. If you write a file that's more than 10 megs, it kills it. There are also limits placed on by the sysadmins to catch this stuff. So hopefully we've got enough checks. It's never malicious stuff that we get. It's always somebody who didn't know what they're doing and found something that we didn't think about to prevent. Either way, that's good. Right? Do that. Try to break things. Right? That's what engineering is all about. Right? Yeah.
What's the meaning of exclamation mark G that you use to?
Oh, good. That's a shortcut. So I was doing gcc demo.c. I don't like typing. You can hit up to do and go through the entire history of your commands. Or if I know, the last command that I ran that started with a G, just run that, whatever it was. Right? So it's bang G and bang L. ls was the last command that I ran that started with an L. Or you can hit up and scroll up and down. You can actually look at your entire history. History. Oh, I don't have a history. Okay. It's probably being stored somewhere else. But yeah, that's another shortcut. Right? Because I don't know how far I have to scroll up for that. I'm so lazy. I don't want to type, and I don't want to look at the entire list. I just know that in my mind I ran GCC at some point. Now that runs into problems if GCC was not the last command that I began with a G, and it was something else like Git related, and I go, I screwed up. Right? In fact, I think you can save yourself from that by hitting Tab. Nope. Okay. You can do partial stuff though too. Instead of Git, whatever the last Git command I did, no, I actually want whatever the last GCC command I did was. So you can disambiguate it as much as you want. to be safe. Okay. All right, so now we get to your question. How do you get it to print in different formats? And that's going to be standard output in C. So the formatted, again, the F, it's going to be printf, and the F, again, stands for formatted. We use virtually the same placeholders. The only difference here is double. You use a %f instead of %lf. So just remember the difference. Scanf, lf. Printf, just an f. Otherwise, the other two are exactly the same. Not only that, but you can provide multiple placeholders in the same print statement. Right? Each placeholder is matched to each variable in the order you specify, So for example, let me come back over here and get rid of this stuff. Let me go ahead and create a couple of variables here. A will be 10, B will be 3.14, so let me go ahead and make it into a double, and then char initial is equal to my first initial right here. I can put that all into one printf line, right? The values are, now the first one I want to print is A, so that's going to be a %D. The second one that I want to print is B, so that'll be what is it again? F. And then finally, char was going to be %C. And then I'll end the line. I'll go with A, B, C. Yeah, go ahead.
So you earlier used LF for the double. What is the difference between LF and
The L is for long. F is just a regular float, which we're not going to cover because it only is 6-7 decimals of accuracy, of precision, I should say. And the LF is for doubles, long floats. But with printf, it doesn't matter because it's smart enough to figure it out and do it for you. Right? So here are the values. Oops, not C, initial. There we go. That was actually an error, a syntax error, because it had no variable named C. And when I do this, I get 10, 3.14, and then 4 zeros for some reason that we'll address here in a second, and then capital C. What if I didn't do it in that order? B, then A. Well, first of all, that's probably going to be a warning. My placeholders don't match the type of variables that I've given, but it's just going to be a warning. You can do whatever you want. Go ahead. Oops. Oh, is it not a warning? It's a warning. 10. Oh, weird. Did it not compile? Yes. CCC. Warning. Come on. It should allow me to do this. Anyway, I don't know why it's not letting me do that, but it's certainly a warning, okay? There's something funky going on under the hood here with memory that probably, just by chance, it happens to be the correct values here, okay? So don't worry about that. But I'll make sure that this is in the notes so that you have it. Now, how can we change this? For example, if I wanted to print a bunch of money, right? So a balance, instead of B, it would be balance. And instead of pi, say that I've got $42.50 in my checking account, right? And I'll print out a message here that your balance is, and then I'll put a dollar sign in front of it because it's dollars. And I'll put it in %F because it's a floating point number. There is 50 cents there. And I will print out balance. Okay? Now, what this is going to do is print out all those zeros. Does that look like money to you? No, that's not usual. So what I want to do is I want to limit it down to just the 2 decimal places. You can provide what are called modifiers here, right? And let me go ahead and go over the notes first. You can further modify the format using modifiers. %n.mf, right? Where n is the minimum number of columns to print, and m is the number of digits, decimal digits to print. Okay. All right, there we go. So let me go back over here, and you can omit one or the other, or both, as I've done in this case. By default, what does it do? How many digits of precision does it to the right of the decimal place does it print? 6, right? 1, 2, 3, 4, 5, 6. All right. By default, it prints 6 decimals of precision. All right. So let's go ahead and change that default. How many do I want to print because it's money? Only 2. So 0.2. And when I do that, I get as expected here. Now, what if I had a bunch of numbers after that? 0, 0, 0, blah, 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 blah. Right? Is it going to print those? You didn't ask it to print those. Right? What if I've got something that looks like this, though? $42.50 and 0.9 pennies. Right? That's what that interpretation is right there. What do you think that that's going to do? It could. Yeah, it doesn't truncate. Truncation is an operation on the variables themselves. The balance is not changed at all. It's simply just changed for the purposes of printing. And in this case, what did it do? It rounded it. Right? So rounding does happen only for printf, though. If you need to actually round your numbers, you need to bring in the math library and use the round function. Right? And then it will take and round it to $43 in this case. Right? Okay. Let's do another example here. Remember that the math library has this pi, right? And we're not bringing in the math library, so but let's bring it in. .h. M.pi, or M underscore pi. That's the value of pi. So let's go ahead and try and get some coding kata here. And try a few things out. If I print out pi and end the line m underscore pi, what is the default again? 3.14 and then 6 digits of precision, 1592, I think. Is that what pi is? Oh, 9.3. What happens to that? What happened there? Yeah, there's a 6 3.141593. Why? Because the next digit is 6, so it ends up rounding it up to 3. What if I wanted to print out 10 digits of precision? Well, you get 10 digits of precision, right? And that'll be 9. You said it was 9, 2, 6, 5, 3, 6. Do you know the next digit after that? Okay, I didn't want to put you on the spot or anything. Printf. What if I only want 1 digit of precision? 0.1 f and the line m pi. What's that going to print? 3.1. Right. 3.1. Right. Now, what about the other side? What if I want, say, 20 columns, a minimum of 20 columns and 10 digits of precision? Right? So let's try that out. It indented over how many digits? There were 10 digits to the right of the decimal point. So that's 10. The decimal point itself, the 3. So how many are left over? 8. And that's how many leading spaces were printed here. So prints 8 leading spaces, then this. That's a minimum, okay? If the amount that you're printing already exceeds that minimum, it's not going to pad it out with anything else. If you want to, you can right or left justify it. But by default, it's going to be right justified. If you put in a negative value, it'll be left justified. That's just another trick. And then you can also do it with integers if you want to. 1, 2, 3, 4, 5, 6, 7. Suppose that there's a leading 0 here in your NUID. In fact, I'll call it an NUID. Right? NUIDs are all 8 digits. Some of them begin with a 0. If I were to print this out by default, your NUID is %d and the line, NUID. Then what's it going to look like? When it prints on your bills or anything else like that you get, does it omit that 0? Nope. Anybody have an NUID that begins with a 0? All right, well, at least one person in here. At least 10% of you have to have that because they're uniformly distributed. But what I can do now is I can print at least 8 digits. That's not going to get me what I want because it's going to end up printing an extra space there. What I want to do is I want to replace those spaces with zeros. So 08D will get me that leading 0. There are dozens, hundreds of little different tricks like this that you can use to get different formatting. The reason that you'd want to do this, of course, is so that you can align the decimal place so that you can print ledgers and stuff like that. Right? Now, take everything that I've done, cut, paste, Java, but using system.out.printf. Right? So I'll put this in as an example for C, and then Java. In fact, all programming languages support printf style formatting. You just have to find out what it's called. Usually it's called printf, but sometimes they don't call it printf because they don't want to, like Python, for example, they call it formatted strings instead of printf style formatting because we're not like those other programming languages. We're special, right? So Java supports printf using system.out or .printf. Right? So the only thing left is standard input in Java, but we already know how to do that, right? Oh, it's I guess I got rid of it, but I could do a big undo here and go all the way back to the beginning. There we go. All I was doing was Control Z, and I held it down until we got back to the beginning here. How do I do standard input with Java? A scanner, and then I scan the system.in, the standard input, the keyboard. And you can mash through the keyboard all you want. Let me go ahead and see what happens, though, if I'm that ID10T user. Please enter miles. Nope, I'm going to enter in this garbage. Nope, I'm going to throw it back to you as a mismatch exception. So a little bit different behavior in Java. If you give it something that it doesn't like or that violates the format, it's not going to give you 0. It's not going to give you some weird garbage value. It's going to throw it back at you and say, nope, you did something wrong. Exception, bunch of red everywhere. That's standard error. Yeah.
Can you make like your own custom error messages?
Yes, we will get to that when we do exception handling. You can surround this with a try and then catch. An input mismatch exception, and then you can do whatever you're going to do here. Right? Details to be determined. Fix that up. Right. Questions so far? No? Okay. Then what we'll do on Wednesday is non-interactive input. Go back over here to the notes. So just as a preview here, interactive input is where you write a program that prompts the user, please enter this number, right? And the user sits there and mashes their keyboard until they hit enter, and that serves as the input. What you're going to witness tomorrow in your lab is non-interactive input, command line arguments. The vast majority of programs are not written for humans. That's the whole point of writing programs, is to do what? Take humans out of the equation so we can go and do whatever we want, right? We can have leisure time. Instead of, we write programs to automate tasks. Now, it's not much automation if you're sitting there asking, okay, we need to add up the quarterly income, so go ahead and enter in the first value. Enter in the second value. Enter, right? That's an old school way of doing things on one of those big giant calculators. Have you ever seen them? Where you enter something and then you pull the big giant lever and it adds. That's an old school, a really, really old adding machine, right? I mean, way before my time, way before even like the old people in our department's time, I'm sure. But that's the old way of doing things. We want to automate things. And the way that we can automate things a little bit is by having non-interactive input. When I run this program, I'm going to take all the input and shove it all at once using command line arguments. The way that what that looks like is I'll put a dot out, and instead of giving it 3, like those A, B, C, 10, 20, 30, all of those are going to be command line arguments that are provided to the program when it runs. And you can access them through these things up here. argc is the number of arguments, arg count. argv is the actual arguments, the argument vector. And over here in Java, you've got args, right? Arguments. Right? And so we'll look at both of those on Thursday, I guess, sorry. All right, any questions? No? All right, then we'll finish up with basics on Thursday with non-interactive input. I'll give you a little bit more, some tooling, using GCC as a linter maybe, and then we're going to move on to conditionals. So instead of having linear control flow, do A, B, C, I need to make a decision here. Do I do A or B? Right? And that's where we come into conditionals.
Are we doing
Yeah.
interactive input in our lab or interactive?
You're doing both in your lab tomorrow. In fact, I think there's a birthday program. You're going to compute how old you are or how old something is. The first version, we give you all the code for that.
Yeah.
The first version is what year were you born? What month were you born? What right? And then you have to enter these all in. And then the non-interactive input is you just give the year, month, day from the command line, and you see how it works exactly the same. All right. See you then.